Now let us see about Archimedes principle. So when an object is immersed in fluid, an upward force is exerted on the object, and this upward force is called buoyant force. Okay, if suppose we are immersing an object in the liquid, then there will be an upward force acting on it. That upward force is called as buoyant force, and this upward force is exerted by the liquid. Now, when a solid body is partially or wholly immersed in a fluid, it experiences a loss in its weight. This loss in weight is equal to the weight of the liquid displaced by the body. So, please listen carefully. So, now we are immersing a solid body of density rho in the liquid, in the fluid of density sigma. Okay, if this is the case, then we can see this solid body will experience a loss in weight. Okay, because we have immersed in a liquid, it is happening, there is some loss in weight, and that loss in weight of the body, okay, the loss in weight, the weight which has been lost, that is equals to the weight of the liquid displaced by the body. So if you are when you are dropping this solid body, this ball inside the liquid, then because of this ball, same volume of liquid would have displaced by this body. Okay, please listen. If you are immersing this ball in this liquid, and if suppose the liquid was already filled up to the rim, okay, up to here it is filled, and if you are dropping this ball inside, then the same volume as that of this ball, that much of liquid would have been displaced. And what is that weight of the liquid displaced? That will be equals to the loss in weight of the body. I hope you got it. So the loss in weight of the body will be equal to the weight of the liquid displaced because of this body which we have dropped inside. Okay, so now let us see the calculations and what is buoyant force and all those things. Okay, uh, so now let us consider the same case. We are dropping a solid ball of density rho in the liquid of density sigma. Now the loss in weight of the body will be equals to the weight of the liquid displaced because of that body. Now we are going to calculate this, what is the weight of liquid displaced, we are going to calculate that, because this is what is equals to the buoyancy force. The force of buoyancy is nothing but this value only. Okay, now let us calculate the weight of liquid displaced. So for finding the weight of liquid displaced, we know mass is equals to volume into density. So volume into density, because it is weight, so into gravity. Now we want the weight of the liquid displaced. So for that, the volume, what is the volume of liquid displaced? That volume is equals to that of the volume of the ball which we have dropped inside. So the volume of the body, the same amount of volume of liquid has been displaced. So instead of in the place of volume, I can take the volume of body only into density of liquid. Why do we take density of liquid? Because we want the mass of liquid and not the mass of body. Mass of liquid into gravity is what? Weight of liquid. Okay, so we want to find the mass of the liquid. So weight of the liquid displaced equals to volume of the body into density of the liquid into gravity. So mass of the liquid is, weight of the liquid is mass of the liquid into gravity. What about the mass of the liquid? It is volume of the liquid into density of the liquid. Volume of the liquid is same as that of volume of the body. So I am writing volume of the body. And density of the liquid, I have to write density of the liquid. So it is sigma. So what is the volume of body? I have to find, because initially they have given the mass, the body of mass m has been dropped into the liquid. So I have to find the volume of the body. Now how do we find the volume of the body? It is simple. Volume is equals to mass by density. If I am using the mass of the body, I have to use the density of that body only. So please see here, volume of the body, I have to find the volume of the body. So how do we find the volume of the body? It is mass of the body by density of the body. That can give you the volume of body. Okay, so if you want to take volume of liquid, then you may not know what is actually the volume of liquid that is displaced. Only the value of volume of body is the volume of liquid displaced. So that we are writing like this. And to find the volume of the body, again I am using mass of the body by density of the body, because the actual volume of the body was not given initially. They have only told us the mass of the ball is m and the density of the ball is rho, and from this I can calculate the volume of the body. Okay, and you please also see volume of the body and volume of liquid displaced are same, so that is the reason I am using here, it is in this way. So a mass by density, that is volume of body, into density of the liquid is sigma, into gravity is g, and this value is nothing but the value of force of buoyancy. Okay, what is the buoyantic force? That is nothing but the weight of the liquid displaced. This is also equals to the loss in weight of the body. Now, if the some weight has been lost from the body, that is what we have calculated, m by rho into sigma g. There should be an effective weight of the body. So yes, we have calculated what weight has been lost by the body. We should also calculate what is the effective weight of the body in the liquid. And what is the effective weight of the body in the liquid? That is actual weight minus buoyantic force. Why do we write actual weight minus buoyantic force? Because actual weight minus the buoyantic force is nothing but loss in weight of the body. So actual weight of the body minus loss in weight of the body will give me the effective weight of the body in the liquid. So what is the actual weight of the body? That is mg. What is the buoyantic force? M sigma g by rho. So from this I am taking mg commonly outside, into 1 minus sigma by rho. And there is another thing, this you might have all known previously. If density of our body is greater than the density of liquid, then the body will go down in the liquid, it will sink. If the density of body is lesser than that of density of the liquid, then the body will rise up. So yes, this is all about Archimedes principle. Yes.